Standard 8.2, given a polynomial in factored or unfactored form, sketch a graph of the polynomial function using degree and behavior intercepts in the multiplicity of factors. Or given a graph of a polynomial function, write the function for the graph. Alright, so let's get our first example. We have an equation, we want to sketch its graph. So we want to figure out what the end behavior is, we want to figure out what the intercepts are, and we want to figure out what's happening at the intercepts. So let's start with end behavior. In order to determine the end behavior, we need to know what the degree of the polynomial function is and whether the leading coefficient is positive or negative. So to find our degree, well, let me define degree first, and we'll talk about how to find it. Degree is the highest power of x when the function is in expanded form. So if we were to expand this function, so take negative 2 and multiply it by x minus 2, x minus 2, x minus 2, because there's 3 of them, and x plus 4. We multiplied all of this out. Our first term would be negative 2 times x times x times x times x, or negative 2x to the fourth. And there would be other terms after it, but the leading term would be negative 2x to the fourth, and the highest power of x here is 4. So in our particular graph, our degree is 4. Now, the fast way that we can get degree is if it's in factored form, add up the exponents on the factors. So you have a factor of exponent of 3 and exponent of 1. 3 plus 1 is 4. That's the degree, and the degree is even. Now we want to look at the leading coefficients. The leading coefficient is the number in front of everything, and that's negative. And in class we talked about how if the degree of a function is even and has a negative leading coefficient, both ends of the graph are going to point down. And we have this in a chart that we developed in class. So if you don't have that chart, please come see me. All right, so the left and right ends both go down, right? Next we want to figure out our x-intercepts. So to find our x-intercepts, what you want to do is take your factors and set them equal to 0. So x minus 2 is one factor, set it equal to 0, x equals 2 is one x-intercept. X plus 4 is a factor, set it equal to 0, x equals negative 4 is your other x-intercept. So we have x-intercepts at positive 2 and at negative 4. Negative 2 is not a factor, so we don't use that to find our intercepts, just the factors that include x. So we have two x-intercepts. Let's sketch those on our graph. So we have an x-intercept at 2 and another x-intercept at negative 4. So a point there and a point there. Alright, how do we find our y-intercept? Well, our y-intercept is what we get by substituting 0 for x. So our y-intercept, let's take our function and put 0 in for x. So negative 2 times 0 minus 2 to the third times 0 plus 4. So this is negative 2. 0 minus 2 is negative 2 to the third, and this is 4. Exponents come first. And negative 2 in odd power is negative, so that's negative 8 times 4, and this works out to be 64. Now you will not be able to use calculators when you do these problems because I'm testing to see if you can graph, so you want to make sure you know your order of operations there. Alright, so our y-intercept is 64. That's a huge number. We're not going to actually count up to 64 on our axis. We're just going to estimate a point right there and just indicate what it is. Alright, great. So now let's sketch our graph. We know that the left end points down, so we're going to start down here. And we draw up to our x-intercept. And when we get to the intercept, we have to decide if we're going to cross through that x-intercept or bounce back down over the bounce against the x-axis. So we take a look at the factor. This is -4, so x plus 4 is the factor. And the fact that it is odd tells us we're going to cross through the x-axis at that point. So we're crossing through the x-axis. Where do we go? Well, we have a y-intercept of 64, so we have to go to that. Where do we go now? Well, we have an x-intercept of 2, so we have to go there. And when we get to 2, we have to decide if we're going to cross through or bounce back up. And there are two clues that kind of help us figure out what's going on there. The fact that the exponent on the x minus 2 is odd tells us that we're going to cross. And the fact that the right end also points down tells us that we're going to cross, because if we bounce, we would be heading back up again, right? So that's what our graph looks like. The left and the right ends both point downwards. We have these two x-intercepts at -4 and +2, and the y-intercept at 64, and it's crossing through all the intercepts rather than bouncing off of any of them. So this is the graph of our function in factored form. Now, it's not a perfect graph. There are some things we can't determine without calculus, but it's the best that we're going to get, and these are my expectations for this class. All right, so our next example says sketch a graph of this function, and if you notice in this example, it's not factored. So the first thing that we're going to have to do is factor our expression before we can sketch it. So when we have 4 terms, we can factor by grouping, which means we're going to group the first two terms together and the second 2 terms together. And in the first group, we have a greatest common factor of x squared, which allows us to be left with x plus 3. Check by distributing. X squared times x gives us the first term, x to the third. X squared times 3 gives us 3x squared. In our second group, these 2 terms have a -4 in common, and we factor them out. We're left with x plus 3. So you can check by distributing. -4 times x is -4x. -4 times 3 is -12. Notice that both of these have an x plus 3. So we're going to factor that x plus 3 out. And what's left over is an x squared minus 4. And can we factor further? Yeah. X squared minus 4 is not completely factored. It's a difference of 2 squares. It can be factored into x minus 2 and x plus 2. So our polynomial completely factored is x plus 3 times x minus 2 times x plus 2. I'm probably going to erase it from here so that we can have some space to graph. All right, so let's figure out end behavior first. You can tell what the degree is. You can add up these exponents and the degree is 3, or you can just look at it because it's already in expanded form. The highest power is 3 there, right? So our degree is equal to 3, which is odd. And the leading coefficient, the number in front, 1 there, is positive. So it's a positive leading coefficient. And because it's odd and positive, if we look at our end behavior chart, our left end goes down and our right end goes up. Okay, what about x-intercepts? So our x-intercepts we find by taking all our factors and setting them equal to 0. So if we take x plus 3 and set it equal to 0, we get -3. If we take x minus 2 and set it equal to 0, we get 2. And if we take x plus 2 and set it equal to 0, we get -2. So we have x-intercepts at -3. And at 2 and at -2. So here at -3, 0. Here at -2, 0. And here at +2, 0. All right, let's find our y-intercept. Now our y-intercept we can get by plugging in 0 for x. Where is it easier to plug in 0? If you plug it into your original polynomial, if you plug in 0, this is 0 to the third, 3 times 0 squared, and 4 times 0. Those all are basically 0, so you're left with -12. Or if you plug 0 in for x in factored form, you have 0 plus 3 times 0 minus 2 times 0 plus 2. This is 3 times -2 times 2, and this is -12, so you can see where it comes from there as well. Either way, our y-intercept is negative 12, so let's plot a point down there, 0, comma, negative 12. All right, so let's sketch a graph. We know the left end is down, so we're going to start down here on the negative side of our graph. We get to negative 3, we have to decide what's happening. Are we bouncing back down, or are we crossing through to the other side? Well, on negative 3, if we look at the corresponding factor, x plus 3, that 1 is an odd number, and when it's odd, we cross through. And then we look at negative 2, and that comes from the factor of x plus 2, and that's also odd, so we're going to come down and cross through. And then we have to go through our y-intercept, of course. We have to go up to our x-intercept, and then what do we do at 2? You can look at the corresponding factor and notice that that's an odd exponent, so cross. Or you can say, hey, I know my right end goes up, so I know I have to finish in that direction. So again, this is not a perfect graph. Without calculus, we can't get there, but it's a good graph of our polynomial. All right, last example here. Let's write an equation for this graph. So what do we need? We need some factors. We'll notice that negative 7 is an x-intercept, so x plus 7 is a good factor. 3 is an x-intercept, so x minus 3 is also a corresponding factor. Now, what exponents go on these factors? Well, we know because it's crossing through the x-axis at negative 7 that it's going to be an odd exponent, so we'll start with 1 here. Usually they're 1s and 2s. I mean, they could be higher, odd and even numbers, but generally I don't plan on giving you examples like that. Here at 3, it's bouncing. Notice it's going up and bouncing back down. And because this is a bounce, it's an even power on the factor, so let's do 2. So here's our equation so far. Now the thing that's left is our leading coefficient. And we're going to figure that out by looking at our y-intercept. Our y-intercept is here between negative 200 and negative 300. Is that the y-intercept of this function right now? Well, let's see. If I put 0 in for x for both of these factors, I get 7 times negative 3 squared. So I get 7 times 9, which is 63. Well, the y-intercept doesn't look like 63 there. So the question is, what number do we have to multiply by in front to 63 to get this negative integer here? Whoops, that's not where I want to go. Let's pull up our calculator. Come on, calculator. All right, here's our calculator. And we currently have a y-intercept of 63. We want a y-intercept between negative 200 and negative 300. So let's see, if I have negative 63, if I have positive 63, I have to multiply it by a negative number. What negative number should I multiply by to get something between negative 2 and negative 300? Let's try negative 4. If I use negative 4, then I get negative 252, which is between, which looks like our y-intercept here. So let's say we have negative 4. So if we put negative 4 in as our leading coefficient, then when we work through for our y-intercept, we get a negative number that corresponds to the y-intercept on our graph. We also knew that that had to be negative because the end behavior is up, down, and only negative leading coefficients would yield that end behavior. So what is our answer? This is our polynomial function that corresponds to that graph. The factors come from the x-intercepts. The powers on the factors come from whether it's bouncing or crossing through the x-intercepts, and the leading coefficient is dependent on the y-intercept here. This is standard 8.2, sketching a graph in factored or unfactored form and writing a graph, writing an equation from the graph.